Hey guys, I thought I'd do a little review for Math 111 Exam 2. So I pulled up the practice exam, the detailed answers, and I'm going to walk through those for you. So I encourage you to do the practice exam on your own before you pull out the answers and before you view this video maybe, but these are available to you. All right, so probability is of an event is -0.075. No, that cannot be a probability. They must be between 0 and 1. The idea of the complement, so the probability of an event, so A, the student is female. A complement, that means not female. B complement means not majoring in business. So the question is, translate the phrase, the probability a business major is male, translate that into symbols. The answer is this one. So the probability that a business major, so that's the given part, so the part after the line, so this one would be the probability of A complement given B. So the part after the line is the given part, like we are only talking about business majors. So the probability that a business major is male, that means A complement, right? Because A was a female, so we would want to know that they're not female. Okay, describe the relationship between two variables when the correlation coefficient R is near -1. That is a strong negative linear correlation. So plain candies, maybe they're M&Ms in real life, come in various colors. Assume that the distribution of color for plain candies is as followed. We have purple, yellow, red, orange, green, blue, and brown. And it says, suppose you have a large bag of candy. What is the probability that the candy is blue? Well, that's this 10%, but the probability would be written as a decimal, so that's 10.10. You draw 2 cards from a standard deck of 52 cards and do not replace the first one. So the first time you draw the card, there's going to be 52 cards in the deck. The second time there's 51. So there's 4 out of 52 and there's 4 out of 51. Find the probability of drawing a 4 for the first card and a queen for the second. So there's 4 4 fours and 4 queens. And it says and, so we know that's multiplication. So 4 out of 52 times 4 out of 51, so that's 16 out of 2,652.006 chance of doing that. Here's another one with the candies. Again, they have a similar distribution. This one, it says, suppose, find the probability the candy is either blue or red. So again, this or makes us think of addition. So the blue was, let's see, what is blue? Blue is the 0.08 and the red is the 0.17. So I simply add those 2 probabilities together. All right, now this is one where we do the regression. Let me pop up Excel since I did it in Excel here. Let's just open Excel. Get a new spreadsheet. Let me make it little here so we can see. So we're going to have X and Y. And I'm going to enter this data, 5.75, 6.25, 6.5, 7, 7.75. March over, 10, 36, 39, 24, 73. Let me pull this down. So what we want is the coefficient of determination. There are 2 ways to do that. I could do it, my favorite way is to put in a chart. There we go, I'll think of it. Scatter chart. So I did insert chart, and then I want to do add a chart element. trend line, more trend line options. And if I go all the way down, I'll see that I'm going to have the equation and the r squared. Let me close that little box. So now we see that. Let me make that a little bit bigger so the letters are bigger. So that r squared is 0.6918, all right? So you can find that on your calculator. You can find r and then square it if you prefer. You can use the very long equation. Please don't do that. I think that takes way too much time. So that's how I found that r squared. So when I say from Excel, that's what I mean. All right, number 9, the College Hiking Club is having a fundraiser to buy new equipment for fall and winter outings. The club is selling Chinese fortune cookies at a price of $2 per cookie. Each cookie contains a piece of paper with a different number written on it. A random drawing will determine which number is the winner of a diner for 2 at a local Chinese restaurant. The dinner is valued at $35. Since fortune cookies are donated to the club, we can ignore the cost of the cookies. Okay, well, that simplifies it. The club sold 718 cookies before the drawing. Lisa bought 32. What is the probability that she'll win the dinner for 2? So she bought 32 out of 718. We reduce that, so it says write the fraction in its simplest form. We reduce that to 16 over 359. I could have also done it in a decimal format. That would be fine also. All right, so compute, here's one of my favorite, almost a trick question, number 10. Because what I want you to remember that if events are independent, there is no connection between those two events. So compute the probability of A given B, given that the probability of A is 0.24. Well, if the two events are independent, there is no connection between them. So I don't care. I often will have students say, well, what's the probability of B? I can't compute this. Well, it doesn't matter because they're independent. The probability of A is just the probability of A. That's all we want. So the probability of A given B is 0.24, because remember, that's the given part is we have to vector in B, but they're independent, so it doesn't matter. So number 11, it's thought that prehistoric Indians, I'm not going to read all of this. We want to know the equation for the least square lines. We want the B portion. So that's the part by the X in this format. Y hat equals A plus BX. So let's go to Excel. Again, I prefer to do it in Excel. I can also do it in my calculator. So we have, let me put an X and a Y in. And again, remember, you can use your calculator, you can use Excel. If you don't have a graphing calculator and needs to use a website called Desmos as your graphing calculator, that is fine as well. So I prefer to simply highlight, insert, scatter, and then I'm going to do add a chart element, trend line, more trend line options, scroll down. I may as well get R squared while I'm there. And let me make it bigger for you. So if I looked at the question and I wanted to know the slope, because the way this is written out, y hat equals A plus bx. They want to know the b, so b is the part in front of the x. So this is the answer we got. Here is the slope. Remember, you can also do it on your calculator. You enter the data in edit. So you go to stat, edit, enter your data, and then 2 variable statistics. All right, so On this one, ignore what I did here. Sometimes I've wanted students to do it two ways, but truthfully, what I really want you to do is just simply remember that the probability, because it says the probability, this is the simple one where the probability for everything is 0.25. It's actually 0.75, but I'll tell you why. So remember that mu equals n times p. So kind of ignore this answer. I did it a long way. Really, there's a shorter way. I should redo this answer key. So mu equals n times p. What is n? N is 4 because it says there are 4 parolees. So n is 4. So mu is 4. Here's the tricky part. What's the probability? So now let's read it. So USA Today reports that about 25% of all prison parolees become repeat offenders. Alice is a social worker whose job is to counsel people on parole. Let us say success means a person does not become a repeat offender. So does not. So they don't want to know how many became, they want to know how many did not. Alice has also been given a group of 4 parolees. Find the probability, P of R successes ranging from 0 to 4. So the question we really want is how many prison parolees expect to not become repeat offenders? Well, that percentage is 75. So 4 times 0.75 happens to be 3. All right, so we would expect that 3 out of 4 would not be repeat offenders. Okay? All right, so in baseball, there is a linear correlation between batting averages and is there a linear correlation between batting averages and home run percentages? Let X represent the batting average of a professional baseball player. Let Y represent the home run percentage, number of home runs per 100 times at bat. Suppose a random sample of baseball players gave the following information. Now, you don't have to create an equation in Excel. I do think it helps you. You might be able to look at this and say, yes, as this number gets bigger, this gets bigger, smaller, but let's just do it in Excel really quick, and then you'll have better information. So, whoops, I gotta give myself just a little more space there. So, we have X and Y. So 0.251, 0.259, 0.29, 0.265, 0.269. And then 1.3, 0.7, 5.8, 9.7. I'm going to highlight that information, do insert, scatter plot, and then I want to do add a chart element, trend line, more trend line options, scroll down, get both my R squared and my equation. Let's make that just a scooch bigger there so that we can all see it better. So now I have an equation, and it says, let me write this equation down here on the board a minute here so that we can see it. So y equals 100.7x minus 23.187. My r squared equals 0.8511. I see that my line has a positive slope. So I know that r, they use a capital R, know that most of the time, that's not important. I know sometimes it is and sometimes it's not. I know that R is gonna have a positive slope, okay? That I know, that's what's important. So the choices are, since R is 0, as X increases, Y remains the same. Well, that would be true, but that's not what's going on. That's not what we found. Since R is positive, okay, so R is positive, as X increases, Y remains the same. Well, no, that's not what a positive R would mean. That would mean the more I practiced in the batting cage, the better my batting average got, right? So that one doesn't make sense. Since R is 0, well, R is not 0, and this wouldn't be true. Since R is positive, as X increases, Y increases. Yes, that is the answer. And let's see why E is not correct. Since R is 0, as X increases, Y increases. Well, that's not true either, okay? So that question was really getting at what is happening, what does R mean? Like, how do we get there? All right, so to open a combination lock, you turn the dial to the right and stop at a number, then you turn it to the left and stop it. You know, this is like your locker in your high school or middle school or whatever. Finally, you turn the dial back to the right and stop at a third number. If you use the correct sequence of numbers, the lock opens. If the dial of the lock contains 10 numbers, 0 through 9, determine the different combinations possible for the lock. Note the same number can be reused. Now, I did this, again, I did a calculation that you don't really need to do because really, you know, there are 10 numbers for each, that we can choose from each time, right? There's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's 9 or 10 numerals, 0 through 9, that we can use. I did it using combinations, but really, you probably knew that. So you didn't really have to do this long combinations to say there's 10 digits for each one. So we have the first, the second, and the third. So I have 10 options on the first, 10 options on the second, 10 options on the third. This is an and situation, right? I have to get the first one right, and the second one, and the third one, or my lock will not open. So that's why we know to multiply these together. So 1,000 is the answer there. So number 15. Consider a binomial experiment with n equal to 6. And I'll say this is a question that when we do this review in a classroom setting, this is one of the ones I answer multiple times. So make sure you're tuned in on this one. So consider a binomial experiment with n equals 6 trials. So n equals 6, and the probability of success on a single trial is p equals 0.20. So my little p is 0.20. We want to find the probability that r is between 0 less than r, which is less than or equal to 2. Now remember, we're talking about discrete variables, okay? Discrete data. So I can have 0, 1, 2, 3, 4. So if 0 is not counted, I'm not using 0.1, right? So what values will I use? I'll use the probability of 1 plus the probability of 2. That's what I'm looking for. So I look these values up on my binomial chart. Let's do that really quick. I realized I didn't open that chart. Let me go to my resources, binomial distribution table. So if n is equal to 6, and my probability was 0.2, so let's see which row. 0.2, that's this row. And so this was my 0.2 row, and I have probability of 1 and the probability of 2. So probability of 1 is 0.393 plus 0.246. Oops, go back to my right page. That's how we get the 0.639, all right? So the probability of 1 plus the probability of 2, I have 0.393 plus 0.246. Again, I just read those off the binomial distribution table. And you have that, so we may need to use that during the exam. I'll probably expect you to look that up. In the classroom, I just give them a little piece because I don't want to have a whole bunch of extra paper laying around. but because you're doing it online, you'll do it in Canvas again. That's probably the best way to do it. All right, a coin is to be tossed 1,000 times. What is the probability that the 785th toss is heads? Well, guess what? Every time you toss a coin, the probability is 50-50, right? So it's 1/2 or 50% or 0.5, whatever. And we're assuming the coins didn't talk to each other. Nobody said, hey, I was tails last time, so you gotta be heads. No, these are independent tosses. Tossing a coin is assumed to be independent. All right, suppose two variables are positively correlated. Does the response variable increase or decrease as the explanatory variable increases? So I have to say, I loved you guys' insight as to the difference between independent and dependent explanatory and response variables. That was great. One of my favorite was how much Kool-Aid you put in yields a different drink. Like the response variable is, what does that drink taste like? So I thought that was great. So good job being creative, and you gave me some cool ideas, I would have to say. So suppose two variables are positively correlated. Does the response variable increase or decrease as the explanatory variable increases? Well, it increases. So if they're positively correlated, as one gets bigger, the other gets bigger. All right. What is number 18? If the probability that an event will happen is 0.27, what's the probability at 1? This is this really important concept that the sum of the probabilities have to add to 1. So I take 1 minus that 0.27 and I get 0.73. If I guarantee this question will be on the exam, and I have a typo here. I know it's a handwritten typo. So note that this is supposed to be a multiplication sign, okay? Make sure you catch that. I really need to rewrite this, so I apologize that it's not. There's some more things that I should add to this. You draw 2 cards from a standard deck of 52 cards and do not replace the first one before drawing the second. Find the probability of drawing a 9 and a 2 in either order. Round your answer to the nearest thousandth. So a 9 and a 2 in either order. So I could draw a 9 and a 2, or a 2 and a 9. And again, that should be a multiplication sign. So I guarantee a question like this will be on the exam. I guarantee it, all right? So correlation, I think this is the last question. I try not to make these exams long, but put the correct labels. This is no correlation, right? It's kind of everywhere. This is a perfect positive. This is a moderate positive. This is a moderate negative, and that's a perfect negative. All right, guys, do well.